How to make Coke. I'm Sawyer.
I'm Jude.
I'm Robert.
Darn it! Those guys are communists, dude! I can't believe they kicked us out. We gotta do something, alright? Let's go find that recipe.
007.
Our mission is clear. Get in, get out, raise no alarms. You got it?
Yes, sir. Sorry to inform you, but got the formula.
Well done, 009. We need to mass produce this via titration.
Sure.
Unfortunately, there's 3 acids that we do not know the concentration of.
The purpose is to find the unknown concentrations, the pH and the pOH of the 3 acids used to formulate the Coca-Cola recipe.
Some might be asking, what is titration? In order to mass produce Coke, we will need to titrate our solution. Titration is the controlled addition and measurement of the amount of a solution of known concentration required to react completely with a measured amount of a solution of unknown concentration.
A titration can help us determine the concentration of acid in our Coca-Cola recipe because it determines the unknown concentration of a substance by adding acid to a measured amount of base mixed with an indicator until the solutions have completely reacted. The indicator is used with a pH meter to determine the pH of the mixture. The equivalence point is reached when both solutions in the titration are present in chemically equivalent amounts. The pH will change rapidly when this point is reached. When the indicator in the titration changes color, this is considered the end point.
So for our balance equations, for our acids A and D, we have the acid hydrochloric acid plus our base NaOH, and our product is NaCl plus H2O. And since all the moles are correct, we don't have to add any coefficients or anything, and it is correct like this. And then for our acid C, which is sulfuric acid, and then our base, we react sulfuric acid and our base for the neutralization to get Na2SO4 plus H2O. And because we have 4 hydrogens here, we have to add a 2 here to get our 4 hydrogens here. And then we also have to add a 2 here to match the sodiums because the sulfuric acid has a charge of 2 negative, so it drops to the sodium to an Na2. And now it's all. Now we need to get on our way to the lab and start our titration. So what we like to do is we like to grab an apron and we like to put it on and we like to tie it around here. See that?
Yes. Start.
And so after my apron on, I feel great, right? I need to get goggles. Do you see these? I want to put them on. All right, put them on. These are already tight, but sometimes you want to tug these straps and make it nice and tight. All right, so now we're all fitted up, right? We need the gloves, okay? We need 2, 1 for each hand. Do you see this? You see this glove? Okay, you see this glove too? So what we're gonna do is we're gonna get it and we're gonna put it on our hands, all right, like this. And then after you have it on, nice and tight, all right, we're gonna get the other one on, just like this, okay? So now we're ready to go.
Step 1. Rinse the base through the burette. You'll need a funnel
3 times.
3 times. And you want to pour about 50 milliliters of the base
Yes, sir.
into the burette. And then you pour it here.
Then what was the final?
And then you wait.
Yes, sir.
So I am going to rinse this burette with acid A, also known as hydrochloric acid. And this process will also be repeated 3 times.
I will be filling up this acid burette with this acid to a little above this 0 milliliter mark. Now that that is said and done, I will let a little bit out to put it at the 0 mark and get rid of air bubbles in the tip.
Boom. The bottom of the meniscus is at 0.
And then we will repeat this process for the base as well.
According to the Coca-Cola factory in Taiwan, Mexico, there are approximately 4.5 milliliters of this secret sauce inside of Coke. So we need to get around, actually not around, exactly 4.5 milliliters, 4.50 milliliters of this so-called secret sauce.
Now we need to drop 3 drops of the phenolphthalein into our mixture in order to correctly analyze the pH and the POH of the Coke.
Now we will add the base to figure out if this is the correct solution for Coke. And once it stays pink, you record how much of the base was used, which it is basically 3.5 milliliters.
So now we will go into our notebook and record all of the information. So trial 1, the initial volume for the acid was 0, and for the base it was also 0. And the final volumes, as we can see, for the acid, 4.5 milliliters and 3.5 for the base. So then the volume used is going to be that minus that, which is 4.5 exactly. Or 3.5 for the base.
At the end of each experiment, we will pour this acid back into the beaker, like so. Now we will redo this process 2 more times to get our trials 1 through 3. And to start, we'll pour this out. And wash it. We will be doing this process with the acid, sulfuric acid. All we will do would be switch the acid, which will be in this barrette. We also do that 3 trials for the sulfuric acid, and then again another 3 trials for the hydrochloric acid.
Repeat all the steps. Remember to rinse it 3 times. So now, after all 3 trials for all 3 acids have been completed, we will finally clean up our workstation. So we will pour the acid into the correct and corresponding container. So for our math, we would check the average volume for acid C, and since we use 4.5 milliliters each time, the average is obviously going to be 4.5 milliliters. But for the base, this was going to change each time. So what we did is we added the 3 volumes used and then divided it by 3 to get our average of 3.77 milliliters. The average molarity of the base is given to us, which is 0.0195 molarity. And then to find the number of moles, so we can use the formula of molarity equals the number of moles over the volume in liters. And since we were given that, we plug in the molarity, and then it equals the number of moles divided by the average volume used, but in liters instead of milliliters. And then our number of moles will equal 7.35 times 10 to the negative 5th moles. And for the average number of moles used for the acid, we'll take the same number as that and then use stoichiometry. And since there is 1 mole of sulfuric acid, we'll put a 1 on top, and then since there's 2 moles of the sodium hydroxide, I'll go on bottom. So we multiply that number by 1/2 to get 3.68 times 10 to the negative 5th. And then to find the average molarity, we'll use the same formula and plug in the number of moles at the top and then the average volume in liters on the bottom to get 0.00818 molarity. So for finding the pH and pOH of the base, we will use the molarity for the base, which is 0.0195, and that will be the same as our average OH minus, which is obviously 1.95 times 10 to the negative second. And then to find the average pOH, we will take this number and find the negative log of it to get a pOH of 1.71. And then to find the average pH, we will subtract 1.71 from 14 to get a pH of 12.3. And then to find the average hydronium, we will have to do the inverse of that, which would be 10 to the negative 12.3, which is our pH, to get an average H3O of 5.13 times 10 to the negative 13.
Okay.
And to find the average hydronium for the acid, we will take the average molarity and we will multiply it by 2 since sulfuric acid is diprotic. And then that will get us to 1.64 times 10 to the negative second for the average hydronium. And then to find the average pH, we will find the negative log of that number, which gives us a pH of 1.79. And then from there, we'll use the same formula to get the average pOH, which is 14 minus 1.79 to get 12.2. And then for the average hydroxide, we will have to do the inverse of the log, which would be 10 to the negative 12.2 to get an average OH of 6.10 times 10 to the negative 13.
For acid A, you can see that the hydronium is a different number because the acid is not diprotic, and hence our base is a different number, which will cause all the numbers to be different, even though we're using the same process as before. And along with these numbers, they're affected by both the hydronium and the average volume used by the base. To reiterate, our numbers for acid A, the molarity of it was 0.084 molar. For acid C, it was 0.00818 molar. And for acid D, it was 0.0456 molar. Compared to 4 other groups' numbers and the average, our numbers are very close, and the pH are exact. Some possible reasons behind difference in numbers is possible errors, such as personal errors, like not exact base amounts for reactions to be completed. A random error, such as different titration burettes causing different numbers. And systematic errors, such as not being able to see the numbers or lines on the burette, and numbers had to be rounded. Although the errors are very small, that is what causes our numbers to be slightly different than all these other groups and the average.